When we say climate change, we divide it into multiple timescales. So, we start with this section called Tectonic Timescale Climate Change. This is important because as Earth has evolved over its 4.6 billion history, the continents have not been in the same place. So, you probably do not recognize this configuration from anywhere, because this is the projection of how the continental movement that is going on will result in the land distribution 50 millions into the future. So, in the past we know that the continents have moved. So, that is at various this is 600 million years ago, 540, 280, 65 when the dinosaurs were running around and just about to get extinct, and this is the present configuration. This tells us very unique things. If the continent here, is it easier to grow glacier? If this connection between the Indian Ocean and the Mediterranean Ocean is changed, if the connection between the Pacific and Indian Oceans is changed because Australia moves, for example, when the Himalayas form because India crashes into Asia, when the African rift happens, when the Isthmus of Panama opens, when the Drake Passage opens. This was open before, it is closed now. So, as the continents move, first thing to figure out, how do we know that India was here 65 million years ago? We will learn that. And once it crashed here, how did climate change? Monsoons evolved. What did it do to vegetation? What did it do to animal life? What did it do to the carbon dioxide levels in the atmosphere? What does that mean for present climate? When did the glacier on Antarctica begin to grow? When did the Greenland got glaciated? And how did the Arctic change over time? When dinosaurs were around, where were they living? What were they eating? How was the vegetation so different? So, it is not just about temperature, it is about ocean circulation, atmosphere circulation, their impact on the evolution of life, and the impact of the life on the Earth's atmosphere itself. For example, right now what is the level of oxygen? How did it come about? And how are these signatures buried in the system? So, tectonic timescale is essentially determined by the geologic timescale at which the continents move, mountains form, the passageways open or close, and we look at what is the weathering rate when the continent is sitting here versus when it may be sitting here. What does it mean for the level of carbon dioxide and the potential for growing or melting ice? Those are the main feedback processes we want to understand at tectonic timescales.